I've always been fascinated by the ocean, and today I want to share something incredible with you. Have you ever wondered why the ocean is salty? It's a question that seems simple, but the answer is surprisingly complex. In this video, we're going to dive into the salty science of our oceans and uncover some mind-blowing facts that might just change the way you think about that vast blue expanse covering most of our planet. Let's start at the beginning. Rivers are like nature's conveyor belts, constantly carrying tiny amounts of dissolved minerals and salts from the land into the ocean. Over millions of years, this adds up. But here's the kicker. When water evaporates from the ocean surface, it leaves the salt behind, effectively concentrating the saltiness. It's like making a cup of tea and then letting some of the water evaporate. The tea gets stronger, right? The same principle applies to our oceans, but on a massive scale. Now you might be wondering, if rivers keep dumping salt into the oceans and evaporation keeps concentrating it, why don't the oceans just keep getting saltier? That's a great question, and the answer lies in what we call the salt cycle. It turns out that the ocean has its own way of regulating its saltiness. Here's how it works. While rivers are adding salt, there are also processes that remove it. For example, certain marine organisms use some of these salts to build their shells. When they die, their remains can get buried in seafloor sediments, locking away that salt. There are also underwater hot springs that can remove certain minerals from seawater. At a molecular level, this involves complex ion exchange processes. It's a delicate balance, but over time, the amount of salt added to the ocean is roughly equal to the amount removed. Pretty amazing, right? Now that we understand where the salt comes from and how it's regulated, let's talk about why it matters. The saltiness of our oceans, or salinity as scientists call it, plays a crucial role in global ocean currents. You see, salty water is denser than fresh water, and this difference in density drives massive ocean currents that circulate water around the globe. These currents are like the planet's circulatory system, distributing heat and affecting weather patterns worldwide. But the impacts of ocean salinity go beyond just climate. Marine life has evolved to thrive in this salty environment. Some organisms have developed fascinating adaptations. For instance, sharks have special cells called osmoregulators that help maintain the right balance of salt in their bodies. And get this, some deep-sea creatures actually use the salt in seawater to their advantage, using the density difference to maintain their position in the water column with minimal effort. It's like they have a built-in buoyancy control system. So there you have it, the salty science behind our oceans. From rivers carrying minerals to the never-ending cycle of salt, to the impacts on climate and marine life, the saltiness of our oceans is fundamental to our planet. The next time you take a swim in the ocean or look out over its vast expanse, remember, you're witnessing the result of processes that have been ongoing for billions of years. And that, I think, is pretty incredible. Thanks for diving into this salty mystery with me. Until next time, keep questioning and stay curious.